All right. I'm seeing that quite a few of us already here. We'll get started. So, a few days ago, I believe I sent out an email regarding switching IDEs or integrated development system. Doesn't really matter what it's called. I recommended Eclipse. Of course, you can use any other ones. We won't be going over how you use them. I believe that's something you could probably figure out on yourself. However, the reason why we're switching is because I feel like Replit isn't enough to kind of, as you might have seen already, Replit is a little hard to use, especially with Java and multiple files. So that's why we're switching off of it onto our own computers. That being said, uh, we won't really be needing it right now. It's just something that you should probably have, so you can maybe follow along with my code or anything like that. Uh, cool. That out of the way, we'll get started with the class. Cool. Okay. So today, let's start with the session 3 review. So here is the homework solution to not yesterday, what am I saying? To Wednesdays or Thursday for you guys. The homework and the solution to which. All right. So I didn't touch anything in the main function. So the only two methods that I created is find fastest runner and find second best runner. Of course, you could change up the method name to like find fastest, find second fastest, whatever you wish. Cool. All right. So let's take a look at the start. So, well, I guess let's take a look at how find fastest runner works. So we have a list of we have a not a list. We have an array of times, right? Up here, which are all integers. Therefore, we're passing it in. I'm going to make this a little smaller so it fits. Well, it doesn't fit anyways. Okay. All right. So I'll just do this, I guess. We won't be needing the entire list. Just the first few should do. All right. Um, okay, so first we have min value equals integer dot max value. So this is something I didn't cover in class, which also didn't need to be covered, I think, because there's another way of doing that, which I'll explain later. But integer dot max value is a sort of treated as a variable, and it stores a number that is basically the max value of any numbers possible. So like it's positive infinity, you can treat it as. So any number that you would encounter is going to be smaller than integer dot max value, which is why I set min value as this. So if I set min value as like infinity, then any number will be less than it. So let's continue to take a look. Min index is -1 because, well, it's not 0, 1, 2. I'm going to make this even shorter. There we go. It's not 0, 1, or 2. So now we go into the for loop. We have now set up min val. I'm going to abbreviate a little bit. Min idx. Here we go. All right. And then we have the for loop. So I started from 0. And it's checking if values I is less than min value. So I recall that index works, index start from 0 and goes to n-1. So leave it like that. All right, so 0, that's 341. And then it's checking if 341 is less than infinity. And as you might know, as you might have guessed it, yes, it is less. Therefore, it's true. And it goes into the branch over here. So it's setting min value as values I. So that means min val is no longer infinity, and it's 341 now. And then it's just setting min index to I, which is 0. So min index is now 0. All right, let's now look at I equals 1. So I equals 1. If values I, which is 273, 273 is checking if 273 is less than 341. And of course it is. Therefore, it continues to go to the next, it continues to go to the these two lines over here. Now min value is 273 and index is 1. All right, now we're moving on to I equals 2. So I equals 2 is checking if 270, all right, so values 2 is 278. So it's checking if 278 is less than 273, which is not. Therefore, it's not gonna go into this. Wait, I'm missing a line. No, that's fine. A bracket should exist over here, but since it's if statement, it should work fine. Either way, it's less than, therefore it's going to go continue the for loop because this condition is not satisfied. Therefore, and then we reach the end of the for loop, which then we return the min index. So it turns out the min index is 1. Well, that 1 is returned. So that's how the logic works. You're trying to constantly find the smallest number possible, and in this case, it's in this case, you just store the currently smallest value, and then you move on to the next index to see if any number is smaller than that. So that would be that for finding fastest runners. Does anyone have any questions regarding how this function 1 works? If not, we'll move on to the second one. All right. Seeing no questions, feel free to ask in chat as well. All right, seeing that there's no questions, we'll move on to find the second best runner. So, all right, what do we have here? Now we have a second index, and we have the min index again. It started from -1, so -1, and min index is find fastest runner. So find fastest runner, recall that it just finds the smallest value. So if we have, let's just make a easier version. 0, 1, 4, 8, 2, 9, 0, 10, that 11. Like that, I guess. Good. Sure, that would do. All right, so the smallest index should be 1, 0, 1, 2, 3, 4, 5. All right, so the main index should be 2. Okay, and then we're moving on to this piece. Now moving on to the for loop. So I of course is still 0. In this case, we're checking if I is the main index. So if 0 equals -1, and of course it's not. So that would be false. Then we move on to the second one. If second index is -1, which it is. So, and then therefore we're gonna go assign this value. Second index equals I. All right, we're done now, and then we'll move back to the for loop. I equals 1. And then it's checking if 1, all right, wait, we just updated it. So this second index is now 0. So we're checking if 1 equals 2, which it isn't. Therefore, we're going to move on to the next statement, which is if second index equals -1, which it no longer does, and it will never be again. So now we're checking if values I is less than value second index. So now we're seeing if right. So right now it's values I is 4. So now we're checking if 9 is less than 4, which is not. 9 less than 4, which is not. Then we're going to continue. Now we move on to I equals 2. And then we're checking if 2 equals 2, since it is. Therefore, we know that this number is the smallest possible number, which goes to the fastest runner instead of the second fastest runner. So therefore, since this is true, we're just going to continue and skip this loop because no number is going to be smaller than that. Therefore, we go on to I equals 3. It's checking if 3 equals 2, which is going to be false. And then we're seeing if 3 is 7. We're checking if 4 is less than 7. Oh, well, okay, well, I'm going to change this to 2 because or else this code kind of gets boring. All right, so we're on to 3. Recall that 2 is less than 4. Therefore, this statement runs. 2 is less than 4. Therefore, now the second index is now second IDX equals 3. And then we move on to I equals 4, I equals 5. Yeah, and then we're done. And 4 and 5 are just these conditions all over again because 6 is larger than 2, 11 is larger than 2 as well. So it's going to be these statements all over again. So I'm not going to go into it. So all right, so now so that will be it for the second piece of code. So the second piece of code, logically, the roadmap goes like this. So first, it's checking if this current index is the same as the smallest index. Is equal to the fastest runner. If it is, then of course it can't be the second fastest runner. Right. So, and then we move on to the second if statement, checking if second index is -1. That means that it's not initialized and we should probably initialize it. So that's just an initialization, one time use kind of code. So we don't really have to care about it. And then the code continues to just be like find fastest runner, which is if her index is less than the current main index. And if it is, then we just switch, then the current main index is now just current index because we're always trying to find the smallest value. So that's how the gist of this piece of this code works. All right. And then I'll go into some frequent errors. But before that, does anyone have any questions regarding how this piece of code works? This is more of a logical kind of puzzle that you have to you solve. The code itself isn't exactly terrible. It's more of how you think through everything. With that being said, we'll move on to some frequent errors. So the first one is array index versus array values. Remember that indices are 0, 1, and 2, and 3 and 4, and values are numbers that you put in. They can be any numbers. It doesn't have to be in any particular order. So something to notice. So something that might have happened is you compared the index with the value. So comparing I is checking if I is less than values, the values with min index. So like this statement would not give you anything of particular use case values min index, because this thing over here is an index and this one over here is a value in the array. So they can't really match up. All right, that being said, we'll move on to number 2. So curly braces should always occur after if, else, for, or while statements. So over here, what do you think is gonna run? Is it gonna run 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 9 done? Or is it gonna be 0 done, 2 done, 0 done, 1 done, 2 done, 3 done? And it's gonna be the first one. So it's gonna print 0, 1, 2, 3, 4, 5, 6, 7, -9, and then done. Because without curly braces, only the line that follows exact only the line that comes right after the for loop is going to be repeated. So if you want to have done in every single line here, you must put curly brackets, and then you could like print I print done like that. Of course, this isn't any particular code syntax. It's just something called I guess, yeah, it's something called pseudocode. So it just tells you the logic of the code without having it tied to any particular coding language, so everybody can understand, basically. Anyways, all right. Now let's take a look at variable initialization. So over here is if I have this piece of code and values are 0, 1, and 2, what would happen? And this, yeah. So that, okay, let's analyze this code actually. It can be rather interesting. All right, so we have min equals 0. And I is 0. All right, in the for loop, we're doing for if values I is less than min. So if 0 is less than 0. Which it returns false. I guess, sure. Yeah, in this case, it worked because it's because 0 just happens to be 0. However, if this value is like, I define I, okay. Okay, yeah, so I should have probably altered this code to like int min equals int idx equals 0 or int idx I. There we go. Return. All right. Ignore that, I guess. Doesn't matter. All right. Let's take this out of the context of this coding, of this piece of code, of this program. So let's say values are -1, 0, because I just realized that it actually would be fine if you set it up like this and you know that all values are going to be larger or equal to 0, because you're running for times. So like, of course, it's going to be at least 1. So that will be actually fine because you know you're setting a number that's absolutely less than all possible values. However, if it is in any other context that values have no restrictions, setting min equals 0 would results in certain issues, such as -1 would never be picked up. I mean, yeah, okay. Sorry. So simply put, it's probably wiser to set the min equals values 0 or the min equals integer max value. So integer min, when you set the min as the highest possible value, then you know it's always going to be fine because any numbers preceding it will always be less. Otherwise, you could probably set it to the first possible number. Therefore, then it's just the same comparison all over again. Yeah. All right. Variable initialization number two. Okay. So we're running a little short on time. I'm gonna skip all the frequent errors. The other possible error is again the same thing. You said that index is zero, which ends up removing one of the possible choices. And if it's zero, then well, you don't get zero, you get one out of this piece of code. You could try walking through it yourself, but we have a lot to cover today, so I'm gonna continue ahead. If you're going to error five, it's defining a method inside a method, which will never work. You have to take this out of it like this. Yeah. Okay, debugging tip number one. Something I strongly suggest doing is use system.out.println to print out values of variables to check if they work properly. It's a great way to know where the issue comes from, and yeah, something you should. And it doesn't really mess with the code at all. Number two, be sure to format your code. This example over here is rather hard to read. You don't know whether there's any errors or not, which turns out there is because the return statement must be outside of it, but it's really hard to see it. Therefore, you should probably put it out. Like, should probably format it. You could always do control. Usually, each editor has like save on format on save, which formats the code as soon as you save it. Sometimes you have to press like format code block or something in Eclipse. Yeah. All right. We'll now move on to actual content of today. We have quite a bit to cover, as you might be able to tell from the table of contents. If we don't get through all of them, we'll just continue next class. That's all right. But I'll try to cover everything. All right. So Java is a very well-known example of what it's called object-oriented programming, or OOP. And Java is a especially good example because it strictly enforces it in its own code or in its syntax. The reason why we would why we would code in this kind of style is because it is representative of our real world. Take and take this example. If we want to represent a baby in our code, what do you think a baby is associated with? Well, its name, its gender, its age, its weight, its height, maybe like, I don't know, some other possible things. And yeah, so object-oriented programming uses something called classes, and classes are a blueprint for creating objects. We'll talk about this later, but objects or classes group together data and methods. Data are what's called attributes, and methods are what's called behaviors in classes. You don't really need to know these content. Well, you don't really need to remember the names. We never really use them. But that being said, these are all going to be attributes. Baby can have a name called string, a boolean called if is boy, integer age, double weight, double height. All right. So so now let's look at why we should probably use object-oriented programming, or why use classes and instead of just using variables. All right. We have now, if we want to have, let's say, define a few babies in our code. If we want to define a baby called Alex, we need to give it a string, a double, and it's possible other values. So we'll skip it, but we need a string variable called name Alex. We need a double called weight Alex. Now, if we want a David, we will need a name David. We need a weight David. Do you see the issue here? What if we have another baby that's also named Alex? Are we going to name it name Alex 2? What about the third Alex, name Alex 3? I don't think that works out very well. What if there are, let's say, 100 babies? Are we going to copy and paste like 7 variables 100 times and give them all different values, or like give them all different names? That also doesn't work very well. So something we want here is the structure. We want to have a baby 1, and then we could copy and paste the same structure, baby 2, baby 3, baby 4, and all the way to baby 100. You see, we grouped all the name, weights, and gender into one like container called baby. and we could just duplicate the container 100 times without actually having to name all the variables 100 times. And then we can place all the babies into an array. Maybe it's called nursery. And then we can maybe put the nursery in, we can maybe put more nurses into nursery. The nurses can also have certain attributes such as age, gender, weight, height, number of years, salary, stuff like that. They can all go into nursery. And then we could place nursery into a hospital. And then at the same time, hospitals might have emergency rooms, nurses, and then emergency rooms can have nurses or patients, and maybe doctors as well. And then you see, this is something. So now we have a really organized or structured way of storing all this code rather than just having, I don't know, like 8,000 individual variables that somehow, I don't know, makes up a data structure. So this is a much cleaner way and much more organized way of sort of listing everything or have storing everything, and it also simulates the real world. Of course, like in a hospital, you have nursery, emergency room, and then in each category, you have their individual employees or doctors, nurses, or patients. All right, so now let's take a look at how does one define a class. So class definition, this is what's called a class definition. I'll go into more details about this in later topics. It's just something you should, just an overview for now. There's also class instantiation, which is basically creating a new object based on this class or a blueprint. This blueprint or class has instructions on what the baby can, on what this object can do, what it has, and yeah, what it's capable of, I suppose. You see there's attributes and also behaviors. A few notes on creating classes. Class names are capitalized. That is, the first name is the first letter is always in capitalized letter, and you should probably only have one class per file. You'll see when there are some other cases during our algorithms portion of this lesson, a class that we might have a few different classes in the same file, and that is for good reasons. I'll go ahead into that later. And then you can have, if there is a main method in a class, then this code is executable. As you might remember, we have coded quite a few classes actually. We have hello world, we have what do we have? We have marathon runner, we have wage calculator. These are all classes. And then for all the main methods inside, makes the class executable, which means you could just run its class. We'll talk a bit about what would happen if we don't have a main method and how we would be able to get that working. But that's for, we'll talk about that later. Now moving on to class fields. Fields are variables that belong to a class or attributes. There's multiple names, as I said. It really doesn't matter, whatever you want to call it. So you can define fields in mostly two ways, and I have a personal preference about one way over the other. But yeah, there are two ways. First way is you type variable name, then just end it like that. Or we could type variable name equals some value. Personally, I prefer this method just because it's a more of a standard practice. And I'll get into how you can assign values later. And then type can, of course, be any data type. It can be string, Boolean, double, or int. All right. And of course, if we want to have siblings associated with the baby, we can just put a list of array of babies. We call that array can store a collection of any kind of variables. I mean, any kind of data structures or data types, and baby is no different. It's just another object they can store. All right. Here is how you would instantiate a baby, which is, or instantiate a class, rather per se. It's something you probably have seen before. It might be similar to the array kind of command you have seen. Recall that arrays are That looks oddly similar, isn't it? So we again use the new keyword to create a new object, and to assign values to the field, we would create constructors to initialize the field. So as you might be able to see over here, we have quite a few fields or attributes that we might want to like control, such as maybe we want to give the baby a name, give it a weight, give it height, and all these must be should probably be done through constructors, which is why I personally do not like defining them ahead of time. That being said, we move into constructors. So a constructor is a special method that can be called when an object is created. So it is used to initialize fields of the object, and there can be multiple constructors per class. All right, so this is the basic structure. You have public class, class name, and then you create a special method that's the same name as the class name. So it's going to be class name, parentheses, and brackets, where you can initialize the variables inside. And also there's the other version, which is you can also pass in a few arguments to it. I can pass in maybe like Alex, comma, true, comma, 26, comma, 14.7 or something like that. So class names you can store, you can be like class name, I'll get into it later. Yeah, so anyways, you can pass a few variables inside, and you could even create more of different kind of configuration of the arguments. Like the first constructor, one constructor could be only accepting the name, the other constructor can accept a name and an age, maybe the other and then you have a next constructor that can only accept the height or weight of the baby. Something to think about whether how many of those you need. So over here, as you can see, both methods are valid. You could create a class, you could create an object both by just calling the first class constructor or the second constructor. So constructors must have the same name as the class. It cannot have any return types because, well, it never should return anything. It's designed to be, it's a special method that is designed to be run and not return anything, I suppose. Normally, or usually, it's used to initialize the fields of the objects. Of course, just like any other methods, you could do anything you want with it, but that's just the standard practice. All classes must have at least one constructor. That is, it has to have at least one of these special methods. And if you don't define any, then the compiler is going to create an automatic default one, which is just that. It's not going to do anything except exist, I guess. Yeah. So here's an example of how a constructor might look for the class baby. So we have a field called name, a field called is boy, and then we are now creating a constructor. The constructor accepts two parameters. The first one is my name. The second one is boy. Now we're assigning the value of my name to name, which is a field of this class, and we're assigning is boy to we're assigning boy to is boy. Something to notice if we want to do something like this. Now that gets a little confusing. You don't Python Java don't know which value or whichever way you want to assign the values. Therefore, but if you still want to have the same name, you do something called this dot. This dot notation is something to reference. So something to tell the code which variable you're referring to. This dot, whenever you have this dot, it's always referring to the attributes of this class. And then name is just, if it's just simply name, then it's always a parameter. Something to note, you could get around without using it, but it's always nice to know and always an extra way of how to write the code. We've gone quite a few topics. So does someone have any questions regarding what we have covered? All right. We'll continue as I guess. All right. Now let's take a look at the methods used. So first method, sorry. So methods are used to perform operations on the field of the classes or any other things you wanted to do with it. They're defined inside the class. So this is a good example of what a method is, or what a method inside a class looks like. You have just the same definition we have always been doing. And then you could also make use of fields that are existing within the class. Of course, you could also pass in extra parameters. Like over here, I have food weight, which is basically defining how much the baby has ate. So, and then I can have a few conditions. I could also modify what the parameter, the field within the class as well. All right, let's take a look at how we can use classes. So classes and instances is the first part. Classes are, remember, I'm going to skip the class definition, but you can instantiate classes like this. So baby Alex, it's a baby called Alex with baby with name Alex and is boy true. So Alex is a boy, Anna is going to be a girl. This is a rather binary way of defining gender, but okay. Now we can access like these fields such as name or gender by using dot notation again. So object dot field gives you whatever the value inside is. So recall that this is Alex. This is recall that this is name. This is boy. So if I print out name Alex dot name, I'm gonna get Alex. If I print out Alex dot is boy, I'm gonna get the Boolean value true. And of course, you can also call call methods. So simply put, baby Alex. So you can just use dot notation again with arguments within the parentheses. You could do Alex dot say name, which would just say the name of Alex. I believe I've defined it somewhere. Yeah, okay. So yeah, it's just my name is Alex. And then if I do dot eat 0.1, the baby's weight's gonna gain by 0.1. Just like that. All right. That would be it for classes. So does anyone have any questions regarding how classes work? We'll cover a bit more down here, but this is the first gist of it. And then we're going to move on to another topic, I suppose. Okay. If there's no questions, I'll continue on to 4.6. So 4.6 is a rather important and rather important topic called references versus values. So let's take first look at what's the difference between values and references. So values or primitive types are basic Java types. They can be int, double, boolean, char, etc. So in this case, the actual value is stored in the variable. So like if I have, if I have boolean is boy, this variable is boy stores the exact value of this of a boolean. It's probably false or true, doesn't matter. So the actual value is storing the variables. And on the other side, reference types are objects and arrays. So they can be strings. Strings is just a list of chars. You can have a baby, which is an object, int array, which is a list of ints. Let's take a look at how to store. Let's take a look at their actual differences then. So in Java, variables are like fixed size cups. So primitives are small enough to fit in the cup without anything else. So you would have bar1, and then it's going to just equals 1. Simple, as you probably have to understand how variables work. And that's a little different for reference values. Reference types are a little too big to fit in the cups. We call that baby has like 7 different attributes and then 6 other behaviors. You can't fit all of them into this one space occupied by the number 1. So that's where references comes in. So the actual content of the object, like actual content of like baby Alex, is stored somewhere else. You don't really know where it is, but just know that they aren't actually stored in the variable itself. Rather, the variable stores the address or the location of how to access this object. So, so the variable doesn't store one, but it rather, so let's have like baby Alex. So what's stored in Alex is not the whole baby class with all the fields. It can't because it's not big enough. Well, the variable Alex is not big enough. Rather, I store baby in a whole different whole other container or other place maybe called location one. And then Alex actually stores this location one and then the variable itself. Therefore, when you call Alex, you know where to look for the instance Alex or this baby. Right. So that's a rather key difference for how you might be able to access those. So the reference, so the object's address location is called a reference, and the equal, which is this, compares the references rather than the actual values. So let's take a look at this. Would Alex1 and Alex2 equal be returned true or false? Although they're both defined with Alex and true, because they are stored as different variables or there's different classes, because they're different objects, Alex1 and Alex2 actually stores different locations, so they would not be the same. In this case, Alex1 is referring to reference 1 and Alex2 is referring to reference 2. Reference 1 is stored at this location with name Alex and is boy true. Reference 2 is stored at the other location, although with the same numbers and values. So they are not actually the same, but you can update using the equal sign to change the reference. So if I do Alex1 equals Alex2, now Alex1 and 2 are both referring to the same reference. Okay. Yeah, so now if you do Alex1 equal to Alex2, it's going to give you true because they are always also all both pointing to this reference. This reference is no longer used and it's going to be removed by Java, something called garbage collection, something you don't have to take care of. All right, I'll give you about 5 minutes to see what would you get for this question. What is I, J, and K after the code runs? I'll wait until 52, I guess. 53, I suppose. You don't also you don't have to tell me. You could just note it down somewhere, and I'll go through the question after the time's up. All right. Time's up. So, all right, I'll go over how this is, and you might have, yeah. So we have I equals 0, j equals 0, and k is also equals 0. So can anyone, would anyone like to, sorry, we'll just run this and see how it goes. Rather a fast way of running the code. So, okay. Ooh, no, do not wish to paste that in. All right. If you ignore the formatting, it should be all right. Yeah. I'll execute it. Okay. Never mind. Guess we won't be executing this. I'll just go through it. All right. So as you see over here, the only thing we have to be care about is do something. Remember that I is 0. I is a primitive data type. Therefore, the value is actually stored inside I. However, X is assigned over here, which means that a new instance is created. Because parameters would always be because you always pass because you aren't actually working with the same variable, whatever is inside of here doesn't really affect the variable itself. So that is going to remain 0, although it's changed 99 over here. I remains the same. Now we're going on to J, right? J is a array. So that means that it's actually storing the reference, not the data type itself. So now the reference is passed into Y. And it's changing whatever the reference is to 99. Therefore, you're actually changing the same reference. Well, okay, you're changing the same actual like list as this one. So J is actually changed to 99 because the reference, because Y and J share the same reference and they're essentially the same thing because they're always pointing to the same set of numbers. Therefore, when you change the set of numbers with by using Y, you're also changing the set of numbers by in J. Similarly, in baby, again, baby is a reference. Therefore, therefore it's actually storing the location of this baby and rather than the actual content. Therefore, you're also passing the reference over here and you're changing their name to 99. So now so now I is 0, J is a array of array with 99, and then baby has a name of 99. That if you didn't understand that, feel free to come back through this sorry, feel free to go back through this topic and read them again. We'll move on to static types and methods. So static applies to fields and methods, means that the field and method belongs to the class and is not unique to each instance. What I mean by that is over here. So everything's the same. We don't really have to really take care of it, except we have a num baby equals 0. Right. And then we're adding num baby every time we assign, every time we create a new baby. Okay. So what would be the value of alex.num babies and anna.num babies? Well, they're all going to be 2 because num baby is a static field and that this variable is shared across all objects and there's only one copy of it. Therefore, therefore the value is shared by all instances. Therefore, when before creating anything, baby num baby is a 0, and then you create baby Alex. Now num baby is 1, and then you create baby Anna, and then it's num equals 2. Same thing for static methods. So something a static void cry baby this baby, and you do this baby dot name cries, versus where it's just simply a instance method where you pin the name plus cries. So both would are valid, but non-static methods can reference static methods, but not the other way around. Therefore, what I mean by that is non-static methods can reference static methods, while static methods cannot reference non-static methods. And static methods can only reference static. This is tongue twister now. Static methods can only reference static methods. And why is that, you might think? Well, who am I? Let's see this piece of code. So you print out the name of this baby. So who am I cannot access. Static is the method itself. So who am I cannot access the name because name is not static. Therefore, it's not unique to, therefore the variable name is unique to each instance of the class, and who am I doesn't know which instance of the name to access. Because recall that static belongs to the entire class, and it is not associated with any specific instance. So, and then maybe you would think, why is main static? Well, main is static because it is the entry point of any program, and is this first method that is called before any classes are defined. Therefore, there's no instance of the class yet, which means it must be static because, well, you can't have an instance method without an instance, kind of like the chicken and the egg. The chicken comes first or the egg comes first. In this case, the main method comes first, then the instance comes next. All right, we actually just covered everything, I believe. Now, the assignment is pretty long, so I'll explain that in greater details. But does anyone have any questions regarding this piece, this object-oriented programming? This is a very key concept that is useful not in just in Java, but in all programming languages. So if you have any questions, feel free to ask. If not, I'm always available through email or through the WeChat group. A few of us are in, or any other methods. All right. If not, we will. I'm gonna go through this piece. I'm gonna go through this assignment in a bit of details because it's a rather long piece of code or instructions. All right, so here is the problem. You're in charge of creating an electronic library system for a small town. The town has 2 libraries, each with a collection of books for borrow. And then customers or readers can print the list of available books, borrow a book, and return a book in each of the libraries. There are 2 classes provided, book and library. You must implement the missing methods to make the classes work. And the first step of this code would be of this assignment would be to implement the book class. So first, a class needs to model books. You can copy and paste the skeleton code over here, books.java. I'm not going to read through all those, but a few things to note. The methods are named, but they are not implemented. So you can think about how each of them works and what they. And then I provided you with a main method. It can be used to test the code, and when you run it, the output should be the following. Well, you can see the following. So a hint that I would give is look at the main code and see how the methods are used, and then fill in the code for each method. Therefore, you know what you're expecting, and you can follow along, follow through the code. The class have a method to get the name of the title, find out if the book is still available, borrow the book, or return the book. So there's a total of 4 that you might be running into. After you have finished the book class, you can then create a library to manage the books. Both libraries have the same hours, which is 9 a.m. to 5 p.m. every day. We might need that later. And however, they have different addresses and book collections. So you can model that by using arrays of book objects. So recall that. I recall how you would create an array of books. You just do book, new book. And then you could have a new book. And then you could and then you can add it to that. My bad. Books. There we go, like that. All right, so the instructions are the same. Copy and paste the skeleton into a file named library.java. Recall that classes must have the same name as the file name. So the main method provide the main method provided creates two libraries and then performs some operations on the books. However, the methods and variables are not implemented, and nor do you know what the parameters are. So you have to work all of those out yourself. Perform some operations, and then you should probably read the main method and then look at compile errors to figure out what methods are missing. One way of how you could approach it is to, okay, well, there's a few notes, but I'll mention this. Try to get a small part of the code working at the same time at a time, and then moving on before you move on to the next part. This allows you to focus on one small piece and finish the code in bite size. You can start by commenting the entire main method, and then uncomment each line at a time. Run the program to get the first line working before you comment the next line. You could usually comment or uncomment lines of code by selecting the line by press Control, then the slash in Windows or Command slash in Mac. Then you can comment a block of code in Eclipse, which is the IDE I recommended, by selecting the code, then choose source, then do toggle comment to comment it out or uncomment it. Also, one thing to note, you cannot modify the main method. It has to stay as is. And then below, I provided you with the Java content to that you should probably that is the expected output. You can compare it with this once you're done. Below, here is a few methods. You should probably have a constructor that creates a new book by using the book title. And then you can mark the book as rented by using borrowed method. Returned is borrowed to check the status. Get title to get the string or get the name of the book. And then here is a main test method. Over here, the main method for library does the following things. First, it creates two libraries with using something over here. And then you add 4 books by doing it like this to first library. And then it's asked, you can print out the library hours. Then you can also ask it, then it should probably have print out library address. Yeah. Notice over here, there's nothing before it. That might give you a hint as to something I've mentioned previously regarding that all libraries have the same hours. They're all from 9 a.m. to 5 p.m. Therefore, yeah, think about whether you would use static or non-static for that. And then we can try borrow books from the libraries by using these methods, and then print the titles out for the available books. And then you can return books, and then yeah, there we go. If you want to have a clean file of it, you click download file and then do Control or Command S to save this Java file somewhere else. Like that. It's stored as a Java file, so you could run it right away. Same thing for libraries. You could download the file, or you could go to the assignments page to see a same assignment, but also downloads. Both solutions are not out yet, nor would I provide any hints because I believe this is a rather actually quite manageable code because, well, there isn't, although you have a lot going on, each thing is not terribly hard, I believe. So a few hints I'll give again. Think about which methods would be static versus non-static, which variables fields will be static and non-static, and then look at what might you need to print out. Like, does the method require a string to be returned? Is this just supposed to print something out right away? Is this supposed to be a Boolean? Um, what do I need to put in? Am I supposed to put in a library for it? Am I supposed to put in, I don't know, like the address of the uh library, something like that. Think through all those when you're coding the methods and defining the fields. That being said, I realized that we did not take a break today at all, so we just end the class early, about, well, apparently 20 minutes early. That's all right, I guess. Um, and then go ahead and work on these assignments. Feel free to email me and or contact me in any methods you wish. Uh, that being said, I will stay a bit after class in case anyone have any immediate questions. With that being said, yeah, I'll see you. With that being said, sorry, I forgot I muted, but feel free to leave. If you have any questions, stay and ask, I guess. All right, how do you import class from another file? That's a good question. Actually, you don't. Uh, you don't need to import at all. I'll show you. So let's say this. Um, well, this gets rather messy. This is the backend of the website, but for simplicity's sake, I'll create a new folder. I hope the sharing's on. Okay. Um, New folder called, what do we name it? Library homework. All right, so we would have, well, the first one would be a book, right? Book.java. It'll be a short class. I'm not gonna provide everything, but book, class book, and it's gonna have a string called title. It's gonna have string author. It's gonna have a book constructor. It's gonna have uh, well, it's gonna have get title, I guess. So gonna be public void public string actually. Uh, Get title. That okay. So it's gonna return the title. We can also have another one called get. All right, simple enough. Now we have a library. Um, over here, Java. Class library. Um, we have a string called address books. Cool. All right. String args. All right. So if you want to create books, you could just go ahead like that. Uh, Interesting. Let's try this actually. Reason, actual, and formatted argument lists differ in size. Why is that? Oh, of course. We need an author as well. I actually know the author of Da Vinci's Code, but apparently it's Dan Brown, so let's just do that. There we go. As you can see, just works like that. Java has something rather interesting is that you don't actually need to import classes from another file because Java automatically loops through goes through all the Java files within the same directory and actually just compiles them. So Java knows which when you do a new book, Java knows to look in the book.java class, Java file to get the class from the book and then use it over here. So there are a few times where you might need to import classes, such as import java.util. I don't know. Let's see. You don't need concurrent. Dot arrays. There we go. So arrays is by itself a class. It's a class that is defined by Python. Sorry, not Python. It's a class predefined by Java. So if you read over here, arrays is quite yeah, there we go. Arrays, this is a definition of array. There's quite a few methods. You don't have to look through these. This is the only time when you have to import something. That is when the file itself is now within the same directory. So this goes for java.util.arrays, java.util.deck, and dot integer, some other stuff. So this, again, wrapping back, the simple answer is you don't need to. It's done by Java already. So yeah, hope that answers your question. Cool. All right, anyone else have any questions? All right. Cool. As always, I'm going to be available through both WeChat and uh, yeah, and email. So feel free to ask me then if no questions occur right now. Thank you for coming, and I'll end the class.